All right, we're going to continue our work with our solving systems of equations, foldable. We've been working with and practicing our skill of graphing systems to solve them. And we found out, here's our practice. This is another video on my YouTube page that we use to create this set of notes for solving systems by graphing. We're going to go on and use a second method. I'm going to show you how we explore solving systems by using substitution. Now just remember, as we move forward, that solving a system of equations is what we do in order to find the value of the variables that make the equations true. So when we practiced our graphing, we realized that the point of intersection was the solution to any equation. It gave us an xy pair. In this case, the solution to the equation was 2 and -3, because that was the value, the ordered pair for x and y, that made both the equations true. Our substitution method is going to allow us to get to, so we're going to work through example 3 and example 4. Get your foldable ready. But our substitution method is going to allow us to use algebra in order to find the solutions to this without having to graph both of the equations in the system to see what their solution is, or maybe if they don't have any solution, they're parallel, or we don't have to graph, we don't have to think about that. Now, what I want to first point out is that when we're dealing with substitution, what we want to do is we want to replace a variable with a quantity. Now, what I mean by that, and there's an intent and a purpose, quantity. What I mean by that is we want to take and look at our two equations and see if there's some way I can use one of the equations and put the other one in terms of just one of the variables. Now, in this particular system of equations, it's actually y equals mx plus b. On a graph, this would start at 5 and have a slope of 2 or 2 over 1. But what I do see is that this whole idea of y equals is actually giving me a quantity that says y is equal to this. Now, y is going to be equal to the quantity 2x plus 5. That's what y is in this system. And what we can do is look at it and go, okay, well, wait, this second equation actually has a y in it. So I'm going to substitute, or I'm going to replace. Since y is 2x plus 5, what I'm going to do is substitute the y in the second equation with 2x plus 5. Because in this system, these equations are working together. And so if y is equal to this, why can't I just pick that up and put it in for y? So I have 3x now plus, not y, but its substituted quantity 2x plus 5 is equal to 10. And this actually turns into a reasonably easy system to solve. When I look at this, I actually have like terms, 3x and 2x. I know I put the quantity in, the quantity 2x plus 5 in parentheses, but actually there's nothing outside of the parentheses. I just wanted to pick it up and say, take that group and put it in for y. So I'm just going to combine my like terms and simplify this equation and go through the process of solving this equation. And when I get done doing this, I'm going to have, give me 5x equals 5. And when I get done, I'm going to know that x in this case is actually 1. Now I am halfway there to solving my system of equations using substitution, because at this point I know exactly what x is. And now what I have to do is go back and say, well, now that I know that x is 1, and I could use either one of these equations. If I know that x is 1, might as well use the first one. My question is, what's y then? So now I'm going to go over, did this first, found x is 1. Now I'm going to go over and I'm going to say, well, y is 2 times x plus 5. So y must be 2 plus 5 is 7. Y must be 7. Let me check to see if that's actually true. If I do 3 times x, 3 times 1, so 3 plus 7, do I get 10? I do. Let's see if it works together here. What happens if I do 2 times 1? Well, I use that one to solve it, so checked it here. The solution to this system then is the ordered pair 1, 7. And just as a reminder, and it might help you too, now that I'm looking at this, I'm like, whoo, I put this in here first. So my first step was the substitution. And then when I got down here, I had to use x equals 1 to find y. And I did that work over here. Could have probably planned that out a little bit better, but that's all right. So there's our substitution method. Our solution is 1, 7. No graphing, just using what we know about algebra. Now, in example 4, we're going to use the exact same idea, but neither one of these equations is as a y equals or as an x equals. But I think it's pretty darn easy if I wanted to put this first equation, x minus y equals 3. If I add y to both sides, I'm not even going to make a whole lot of space doing it. I'm going to find out that x is equal to y plus 3. So right out of the gate, I'm going to get rid of that. I'm going to use this one. And then I can look at using the same method. Here's my x. There's an x there. Put that quantity in place of it. So I'm going to come over. Actually, I'm going to go below so my work is a little better organized this time. Y plus 3, putting that in place of x, plus 2y equals negative 6. This x is y plus 3 now, because x was equal to y plus 3. I'm going to gather up my like terms. I've got y and 2y. 3y plus 3 equals negative 6. And then I'm going to go through the process of solving this for y. Once I know what my y value is, I'm going to go use it to help me find out what my x value is. Finish undoing. I hope you're noticing that I'm not talking through all these steps of solving as much as I may have in the past, because I'm assuming you're getting better and better at it and you can follow along and be thinking ahead. Now that I know that y is negative 3, why don't I use this equation here? X plus 2 times negative 3 is equal to negative 6. So now I'm just using it. I found y and now I'm putting it in place, put the value in place of y that I have. X minus 6 equals negative 6. 2 times negative 3 gave me x minus 6. And if I solve this equation and add 6 to both sides, I'm going to find out that x is equal to 0. Now I do want to go and check this. Let's go look at the combinations. My original equation, probably shouldn't have put an extra line through it, x minus y equals 3, is 0 minus negative 3 equal to 3. It is. It's true. Now let's go here. Is 0 plus 2 times negative 3. 2 times negative 3 is negative 6. 0 plus negative 6 is equal to negative 6. Cool. I'm confident that my solution is 0, negative 3. If these equations were graphed, they would intersect at 0, negative 3. Good luck.